Welcome to another Tech Zone Tech Talk. I'm Alex, Director of Cloud and Engineering in Visma. In today's talk, I want to show you how Visma approaches DevOps, how our development teams work, and I hope to show you that DevOps makes a huge difference. So my goal is for you to walk away from this talk thinking that DevOps is a really good way to develop and deliver and operate cloud software. Now, since DevOps is understood differently by different people, let's start from the beginning. So about 20 years ago, companies had both development teams and testing teams working separately from each other. Developers would develop, throw a new version of the software over the wall, and testers would test. If the testers found bugs, they would throw their findings over the wall back to the development team. And because of this wall, the two teams didn't necessarily communicate very well. They didn't take advantage of each other's competence throughout the development lifecycle. So bugs would very often be found much later in the process than necessary. And of course, then it's more expensive to fix. For instance, developers have moved on to other tasks. So today, most teams have teared down that wall between these teams, right? Most companies have development teams that is responsible for both development and testing. In fact, testing has become a team responsibility, and the team may have testers with deep testing or quality assurance competence, but developers will implement automated testing because they're professional developers. It's part of the engineering and craftsmanship. Now, let's think about having a separate operations team. You have an operations team who is responsible for running something that they didn't build. And you have a development team that is not incentivized to care about how the software is running, or at least how it is to operate. So logging, monitoring, things that are really important for the end result is not necessarily a priority. The development team does not have easy access to operations competence either, which means that operational problems that could have been identified and prevented early are discovered much later when it may have caused damage and it's much more expensive to fix. So we know what the solution, at least one solution to this problem is. We tear down the wall again. So in this situation, we have one team that is responsible for both development and testing and operations. We have a team where development and operations competence is continuously integrated on a daily basis. And that is what we mean by DevOps in Visma. Now, in Visma, we call these teams service delivery teams. We have about 65 of these teams today, and we're hoping to cross 100 in the next year or two. On average, there are about 8-9 team members in this team, and we try to stay below 10 in the single digits. A service delivery team might be responsible for an entire Visma product, or they can be responsible for one service or a set of services that is a part of a larger Visma product. But in either case, all of these different service delivery teams that we have, each team has full and exclusive ownership to their own code and to their own infrastructure. So no code or infrastructure or data is shared between teams except through APIs. And that's a really important point. This team, a service delivery team, is not responsible for just building a product and throwing it over the wall to someone else. It's called a service delivery team because the team is continuously responsible for delivering a service to their customers, whether that's Visma customers or another or multiple internal teams. And that end-to-end responsibility includes everything from design, development, testing, to things like deployment, infrastructure, monitoring, and handling incidents if they arise. So to handle this end-to-end responsibility, naturally the service delivery team needs to be very cross-functional, right? They need to have wide competence. So to give an example, someone will have the infrastructure engineer role. And that means that they have probably the deepest competence when it comes to infrastructure and operations in the team. But of course, they are responsible for distributing that knowledge to the rest of the team so that they don't become a single point of failure or a one-person operations team within the team. So to summarize this setup, the service delivery team has the authority and the competence to handle that end-to-end responsibility. And that means that they can be very efficient. They can handle most tasks within the team. So that means that we're very intentionally avoiding handovers between teams, and we're avoiding any organizational dependencies that we can avoid, because we know that as soon as you move a task outside of the team, it can take 10 or 100 times longer. And often the quality of the execution of that task can also be lower, right? Because someone external to the team doesn't have the same context, the same knowledge about how the service is built, who the users are, what are the important things to know within that domain, etc. And it's because the service delivery team has access to many different types of competence: development, testing competence, operations competence. Because they have easy access to all of those different types of competence throughout the entire development lifecycle, the team can make better decisions. Now, all service delivery teams in Visma that work like this are operating or running their software on a public cloud platform. And in Visma as a whole, we use Amazon Web Services, we use Microsoft Azure, we use Google Cloud, but any one individual team will usually only use one of these public cloud platforms. The reason I bring it up is that public cloud has been and continues to be a critical success factor for Visma's own DevOps transformation over the past 5-6 years. And there are lots of different reasons why using public cloud technology is very beneficial both to Visma and our customers, but there is one very particular reason I want to highlight for the purposes of today's talk. And that is self-service. Self-service for developers is necessary if you want to implement DevOps. In Visma, a service delivery team will own and manage their own public cloud environments. So that means that one team can have multiple AWS accounts, Azure subscriptions, or Google projects. And the fact that a service delivery team can manage their own infrastructure, either through an easy-to-use graphical user interface, or better yet, through automation by using the APIs that these public cloud platforms provide, that is enormously empowering, right? There is no more waiting for someone to do something. You don't have to send a ticket and wait for 2 weeks for something to happen, or 2 days, or 2 hours. The team can do whatever they need to do when they need to do it. They're empowered. Now, of course, some of you might be wondering, how do you balance empowering developers to be able to act quickly, but then at the same time protecting the production environment and customer data? And the answer is that through policies, processes, and tooling. Normally, in fact, no one in a service delivery team has access to the production environment. We follow the principle of least privilege. So when anyone in a service delivery team wants to make a change to the production system, normally, of course, that's done automatically through code and through an automated delivery pipeline. So in a normal situation, no one needs access to any production environment. Now, if someone needs access to a production environment, a developer in a service delivery team can request access for a limited time, usually an hour or two, depending on the task. And they will request access for a limited scope. So not access to be able to do anything, but for what they need for that particular task for a limited time. And normally that request needs to be approved by the service owner, the person in charge of this service. But to make sure that this doesn't become a bottleneck in an emergency situation, some people in the team can be pre-approved. So if they request access, that will be automatically and immediately approved. So if something goes wrong in the middle of the night, there will be someone who can address the problem. And of course, all of the requests, the access, etc. is logged. So we know who accessed what, at what time, for what reason. So now I want to show you a couple of examples where DevOps makes a difference in the development process. So let's imagine a standard agile development process with automated delivery pipelines. I think this is representative for most service delivery teams. The thing is that before a team starts implementation of a user story, they can take advantage of the wide competence that they have in their team. Different roles can get together before implementation and can try to identify risks, problems, and possible solutions. So people in the team can ask things like, do we have any performance or scalability concerns with this feature that we're implementing? Are there any particular cloud services on our public cloud platform that we can leverage instead of building ourselves? What kind of monitoring do we want in place for this feature? Are there any dependencies for this feature that can break? And if they break, how do we want to handle that gracefully in our application? Where do we focus our testing efforts? All of these things can be asked, discussed before implementation, and that's much cheaper than discovering problems X number of hours, days, or weeks down the line. And without the end-to-end responsibility and without the cross-functional competence, you can't really ask and answer all of these types of questions. So in order to be able to iterate quickly, service delivery teams will employ automation, right? They will define their infrastructure that they are responsible for as code. They will invest heavily in automated testing. And when any implementation is done, whether it's a bug fix or a new feature, whether it is software changes or infrastructure changes or both, those changes will be applied automatically to test environments. They will be tested, and the changes will end up in a production environment. The next thing I want to highlight from a DevOps perspective is how our test environment design and philosophy around testing is also aligned with this idea of having autonomous teams that are able to work as independently as possible. Now, first of all, this should not be a surprise if you've been paying attention. Service delivery teams own all their environments fully and exclusively. But what I want to discuss for a moment is how we use them. So when code enters the main branch, a new version is built, tested, and deployed automatically to our first test environment, and we call this internal test. And for some teams, this might be a stable and permanent environment, but for other teams, it might be ephemeral, a temporary one that only runs as long as is necessary for the automated tests to pass. Now, the internal test environment is only for automated internal testing. And what that means is that any dependencies that our software may have has been, as far as possible, replaced by test doubles. So that might be a method stub that just returns a hard-coded value, or it might be a more complicated mock object over the wire using software like mock server. But the main goal is to do as much of our testing as possible without depending on anything outside of the team. So in internal test, there is no manual testing. Humans generally do not use the internal test environment. Now, if the automated internal testing is successful, the version is promoted to the next test environment, which we call staging. And this is where we do the actual system integration testing with live integrations. So now we are actually verifying that our software's interactions with other systems actually work as expected. So in internal test, we made some assumptions about how those external systems would behave, right, when we created our test doubles. But in staging, we are actually verifying the real thing. Now, this way of working means that in a perfect world, in the staging environment, we should only discover problems that are either caused by our own incorrect assumptions or problems that are actual bugs in those external systems that we are using. So we want to spend most of our time, most of our testing effort, testing our own software. And there are three major benefits of this approach. One is that it's faster because we spend less of our time communicating with external dependencies, which tend to be slower. The second reason is that we are protecting the reliability of our staging environment. So whatever is going on there, whether it is manual testing that we do, because sometimes you have to, whether it is performance testing or some other team is running integration tests towards our staging environment, all of that is less likely to be interrupted by a flaw in our own software. The third one, and maybe the most relevant one for the topic of this talk, is that if any of these external dependencies are down or broken in some way, we are a lot less dependent on those to be confident in our own software, right? So it has a smaller impact on our development and delivery process. Now let's talk about security. And, based on what you have seen so far, how do you think we work with security? I don't think you'll be surprised to learn that we consider security also a team responsibility, and that we have injected security competence into the service delivery team. We have a security engineer in every team, and again, that means that while they may have a special competence or special interest and motivation around security, they're not the only person in the team with security competence, right? They have the same responsibility as an infrastructure engineer to distribute some of their knowledge to the rest of the team. We also have a company-wide security community, and we have a learning platform where developers or anyone working with code can sharpen their security skills. Now, if we go back to the overview of the development process that we looked at earlier, I want to point out again, where the security engineer fits in. The answer is through the entire development lifecycle, but again, to illustrate, in the refinement phase before implementation, right, the security engineer can be present in those discussions where people ask, what kind of security risks do we see for this feature that we're working on? How can we mitigate those risks? And in those discussions, it very quickly becomes apparent how valuable development, security, and operations competence is together. We also take advantage of many different security tools in our development and delivery process so that we can detect possible security vulnerabilities as early as possible. So we have tools that will look for vulnerabilities in our own source code, and we have tools that will look for known vulnerabilities in the third-party libraries that we consume. We also have tools that will scan the web layer of our application, and any security findings from these channels that I have mentioned or from the many other security tools and channels we have, findings are continuously handled by the service delivery team. And since many of these tools are part of the pipeline, we can run these checks many times a day. Another thing that our service delivery teams do on a regular basis is to perform a security self-assessment. And this includes walking through and understanding what data are we actually processing in our system. How can we protect that data? Another exercise is about the attack surface of the system, mapping that, where are possible entry points for attackers? And is there any way we can reduce the attack surface? And then, of course, mitigate the threats to whatever attack surface we have. And in these exercises as well, it very quickly becomes apparent that development, security, and operations competence is useful to have in that situation. So now I want to cover how our service delivery teams work to deliver a reliable service with good performance. And it starts with knowing what the targets are. What's the target performance? Which actions are actually performance sensitive? Maybe there are things that need to complete in 20 milliseconds, while other things can process for 2 hours. What's the target availability? How many minutes of downtime can we afford every month? And if something should happen to go wrong, how quickly do we need to get back on our feet? Do we need to get back in 15 minutes if there is a disaster? Or can we afford to wait 8 hours? And probably for many it's tempting to say, well, we want as good performance as possible, of course. And that's understandable, but that's not really a target that will help you make any decisions. And likewise, it's tempting to say that, well, of course I want 100% availability. I never want the system not to work. But what that actually implies is that you should invest an infinite amount to try to guarantee 100% availability, which is not a realistic target. So our service delivery teams will use their cross-functional competence to map out their requirements, which of course can change over time, and the implications of those requirements for their architecture, for how they do testing, for how they do monitoring, etc., etc. As you probably expect by now, service delivery teams are responsible for designing and implementing and reacting to their own monitoring. So that includes both the operational monitoring, where the goal is to prevent and identify operational problems. And it also includes innovational monitoring, where the goal is to learn how the product is used and how it can be improved. The service delivery teams will create alerts for situations that require human attention. So the question is then, if a monitoring alert goes off in the middle of the night, what happens? And how we do this is that a service delivery team can choose to send a subset of their alerts to a centralized alert center team in Visma that is staffed 24/7. If a service delivery team wants to handle everything themselves, they can do that, but most teams choose to use this service. When the alert center receives an alert, they will follow predefined instructions from the service delivery team for that particular alert. And that's one way for us to, for the service delivery team to retain ownership and responsibility. When the alert center handles an alert, there are generally three possible outcomes. So in one case, if the alert center identifies that this alert is actually a false positive, there's not actually a problem, or maybe it resolved itself really quickly. In that case, they don't escalate to the service delivery team. So if this was in the middle of the night, the service delivery team can continue their dreams. The second possibility is that the alert center will resolve the problem according to the instructions. And in that case as well, they don't need to escalate immediately to the service delivery team. Of course, they will be informed when they get to work in the morning. Only in the third example, if the alert center is unable to resolve the problem, then they will escalate to the relevant service delivery team according to their instructions. So that could be, a list of names, phone numbers, etc. And depending on the business criticality of that service, many service delivery teams will then want to be escalated to and react and try to troubleshoot and resolve that problem regardless of the time of day. If an incident has had customer impact, then the service delivery team will perform an incident review after the incident has been resolved. And of course, the goal of this is to learn as much as possible from what happened and see if there are improvements that can be made either to the system or to processes to make sure that similar things does not happen again. And again, the service delivery team is responsible for running the incident review, but we do provide someone centrally to be available at least, who can facilitate with someone that has incident management experience, and they can assist on request. But here as well, the team is in the driver's seat. In order to protect important data and to minimize impact of possible failures, service delivery teams will to some extent plan for failure. And again, this is also an area where it will be apparent how important DevOps is. A service delivery team will start by defining their recovery objectives. And here, of course, you need domain knowledge and a business perspective to answer questions like, if something goes wrong, how quickly do we need to recover? If there is a major disaster, how much data can we afford to lose? When you know your recovery objectives, the next step for a service delivery team is to identify possible failures. So there are many ways to do this. The most efficient way is usually to start with, what have other people planned for? What are the most common things to plan for? What kind of failures have we experienced in the past? So teams will look at things like corruption of data or major component or dependency failure. Very common failures that can happen, right? That we should be prepared for. Teams can also do paper exercises. So they will, analyze their architecture, see what happens if this component fails, if that component fails. Some examples could be, for instance, if we try to insert a record in our database, but that fails, the database is unavailable, the API call fails, the query fails, whatever it is, what happens? How does the application handle that? What if our caching layer stops working? What if our Lambda function times out? What if a node in our database cluster suddenly crashes? What is the impact for the user? And in some cases, teams will also do practical testing, right? So taking the next step. A team may intentionally trigger an out-of-memory error on one of their database nodes to see what happens, right? Maybe we are using a managed database service on a public cloud platform, and it's designed to automatically fail over. Then we test, does that actually happen successfully? And critically importantly, when that happens, does our application layer handle that, right? Does the application still work for the user? Or is there some delay? Should we display some message to the user? Things like that. So you need to look at both the operations perspective and the development perspective. When a service delivery team has generated a list of possible failures, it's usually not practical to plan for everything, right? So you need to decide which scenarios are most important, and that you need to weigh both likelihood of something happening and the impact of that happening. So the team will then pick which scenarios they should plan for, and of course this can change and improve over time. But then for each scenario, the team will determine, can we recover from this failure if it happens automatically? Or do we need to describe a manual recovery procedure? The team will decide, do we want to test this scenario every month, every quarter, every year? Is it so unlikely to happen, or is it so expensive to test that we don't want to test it? Can we take that chance? The disaster recovery plan is very much a living document, right? So in the incident review that we discussed earlier, that's where a team might ask, do we need to improve our disaster recovery plan? Do we need to improve this scenario? Do we want to change from a manual recovery to an automated recovery? Or did we have a failure that we didn't plan for, but we should have? Or at least now that we know this can happen, we want to be better prepared in the future. Finally, I thought I would share how we make it easier for people to get an overview of all of these things, and how we try to guide teams towards this way of working. So a Visma team can onboard their software to at least 3 indexes. We have one index for security, we have one for DevOps, we have one for architecture and technology, and the service delivery teams that we're talking about, they will use all 3 indexes. And when we start measuring some Visma software on these indexes, the team that owns that software will set an ambition level. We want to be platinum on security, or we want to be gold on security. We want to be gold on architecture and technology. Maybe it's okay to be bronze on DevOps, right? We have many different products. It makes sense to invest a lot in many of them. For some, maybe not so much. Then after a score, an ambition level, a target tier has been set, we measure a score for the software on the different indexes every day. So I want to show you some examples of that. But this means that, for my software, I want to reach platinum on security, but right now maybe I'm only on silver level. So then this index will, of course, make that visible, and I can track improvement over time. I can see steps I can take to improve my security score. So in the security index, we mainly measure whether or not the different security services that we provide centrally, whether or not they have been used, and whether or not there are unresolved findings from those tools. So this means that if you are not scanning your source code for vulnerabilities, that will stick out as a sore thumb on this index. You will see that, right? You will start scanning your software for vulnerabilities, and most likely, if you haven't done this before, there will be findings. And the more findings you have, your score will go down again, right? Your score goes up when you start using the tool, because you get credit for starting to use the tool that scans your software. But then your score can go down because there are lots of findings. But then, of course, as you resolve, analyze, fix the problems, your security score will go up again. And that's generally how it works for all of these different security services that we provide. Now, in the Visma Cloud Delivery Model Index, we measure DevOps metrics. So if your software is deployed frequently, let's say daily, and your deployment process is very fast, let's say less than 30 minutes, then you will get a good score on this index. If you are making manual changes to your system instead of having changes going through an automated delivery pipeline, then that will be reflected in a lower score on this index. Similarly, if you have many operational incidents, the software doesn't work for some reason, then your score will go down. But if those incidents were discovered by monitoring, if you had good monitoring and were able to catch these problems when they arose, then your score goes up. You get credit for that. And similarly, if you have incidents, but you make improvements based on what you learned, then you will get credit for that as well. So your score will go up. Third and final index is the Architecture and Technology Index. And here we measure things like, is your infrastructure defined as code? Generally, for all service delivery teams, that is true. We measure, are you able to deploy new versions of your software without any downtime, without any negative impact to the users? And for all service delivery teams, that answer is also true. Do you have an overview of your technical debt? Do you monitor that over time? Do you know your performance objectives? And again, for the service delivery teams, this answer is yes. If you don't have a disaster recovery plan, or if you haven't reviewed it in the past year, let's say, that's also something that will stick out as a sore thumb. So these indexes also serve as a reminder when periodic tasks like that come up again. The main purpose of these indexes is to enable Visma teams, Visma companies to make better decisions. We provide guidance on what tools exist and what outcomes are desirable. It's a gamified system, so it motivates improvement over time. And it's a way for a team to make risks visible, right? So that they can be addressed. All right, time for the takeaways. What I hope that you take away from this is that in Visma we aim and value very highly cross-functional autonomous teams that have end-to-end responsibility. We think it's super important that teams have full and exclusive ownership for their own stuff. We avoid organizational dependencies like the plague, except through APIs. We like APIs. And, DevOps is not a product that you can buy. It's not just automating something. That can be part of DevOps, but it's not the most important thing, right? Taking your operations team and calling them DevOps engineers, that's not DevOps either. It's the daily integration of development and operations competence and security, for that matter, in the entire development lifecycle. For us in Visma, public cloud has been a critical success factor. And the most important thing, DevOps is what allows us to develop, deliver, and operate software securely and successfully. And if you're not doing DevOps, I highly encourage you to consider it. Now, thanks for staying with me to the end. If you have any feedback, if you have any questions for me, just leave them in the comments.